All right, so let's get this kicked off, Nikhil. How does that sound?
Yeah, it sounds great.
Okay, I'm just going to go right again back to my webcam, and we'll just do a little presentation here. Again, John with Rocky Mountain Unmanned Systems here in Salt Lake City, Utah. What we're doing is a follow-up on basically doing photogrammetry as well as thermal imaging of a solar field. The original webinar we did with Nikhil last year covered a little bit of some of the stuff that they were doing out there, but then as well, we just recently did one just a month ago or so that was telling some of the new stuff that they've been doing and working on, and kind of as far as workflow and some of the processes they've done. We wanted to cover a little bit of that today, and then also go specifically into how to do correct imaging and capturing images when it comes down to doing solar panel inspections. I just wanted to give you some general information that basically RMUS, we do a lot of testing. We listen to feedback. We listen to a lot of different channels as far as people trying to do this type of work. We really value anybody's input when it comes down to making workflow do what it needs to do, recommended cameras. We try to listen to this because we're not out there every day doing this type of work as far as John and the staff of RMUS. We want to make sure that the guys are using the right stuff, but we do have the opportunities to go out and actually spend time with different industry, whether it's roof inspections or we're doing electrical line inspections. And then today, as we're talking about solar field panel inspections, we have the opportunity to go out there, test it, evaluate it, and then work with guys like Raptor Maps to go ahead and then move from processing and kind of getting the workflow down, understanding of equipment that is needed, how to properly get the images, and that's what we'll talk about today, onto processing and how to get those images to your customers. It's really important that for the most part we understand that. So Nikhil, I'm just going to go ahead and have you briefly talk a minute about Raptor Maps, just a quick little spiel about what you guys are doing, and then we'll get into the guts of what we're doing today. So
absolutely, yeah, no, that's a great introduction, John, and I think what we're doing today is really important because very rarely do you get to see what it's like to go all the way from, I'm taking my drone out of the box all the way to here's what I'm delivering to my client. And there are a lot of questions that people have in between. Sure. Raptor Maps, we are a software company. We provide analytics for drone-based asset inspections. So our customers are anyone and everyone who flies a drone. So typically today we're going to be talking specifically about solar. We have done a ton of work. We're really leading the industry when it comes to solar and solar software. And so we want to make sure that when you guys are out there, you're collecting the absolute best data that you can and making really good use of your time in the field so that when we generate the analysis of the solar farm, it's the best it can be, and it's as fast as it can be. So that's really our goal here to teach you guys today.
Yeah, and so just let's make sure that everybody understands that you're basically a web-based program, correct? You are uploading images, you're doing processing, and then giving that access to both your client as well as possible their customers. Is that?
Yeah, absolutely. And it definitely goes beyond, the imagery is a really important component of it. And we'll talk a little bit about some of the other data that we utilize as well, because it's not just the drone images, it's that working in conjunction with the other asset information to really pull it all together to be able to, for you guys to be able to give your clients exactly what they're looking for.
Yeah. Okay. So, well, let's go into doing what I would call, how do we set up the drone? What is it that we're looking for? Recommended imagers, and we'll just kind of cover a little bit of this. Feel free during this time to, if you have any questions during this presentation, we'll have about 10 to 15 minutes of me talking about drones and some of the other stuff that's out there as far as equipment goes. And then we'll hand the time over to Nikhil to explain after we've done the images, we've done them correctly, then showing how that works for them. And then we'll answer questions at the end. But feel free to go ahead and put questions during the presentation. I'll try to answer as much as I can, but please understand we'll be following up Nikhil and his staff will also be following up if there's any unanswered questions today. So this is about an hour broadcast or so. We'll just be doing that, and then by the time we're finished up, we'll try to answer as much as we can and go through that. Sound good, Nikhil?
Yes, it does. Sounds good.
So one of the things that we wanted to talk about is some of the equipment out there. And so for today, I've got basically an M200, and on the bottom of that, I'm using a recommended 13 millimeter 640 imager. From there, we can do this in RGB initially to basically build a map to go out there, because one of the problems that we have when trying to do brand new sites that have just been built or just been done, we don't always have a map set up and ready to go as far as planning the software to actually do it. So I did some type of inspections not maybe 2 years ago or so, and the Google website did not have any of those, did not have that set up whatsoever. I mean, there was no images, nothing to work with. It was just a wide open plain field. And that could be a small issue when you're talking about, you know, trying to map the space that you want to map, as well as figuring out the borders and whatnot. So you can do an initial RGB, send those over to Raptor. They can then create a stitch of it, and then possibly use that as a reference to when we're going to come back and do thermal. If we're going to do it at the same time and collect data at the same time, that can again be problematic if the Google is not updated with that. So there's ways to do this. There's ways to create maps if you need to, from updating the information into some of the software that's out there to include PixMapper, using GS Pro, Drone Deploy. There's a number of them. So these are programs that are just, or software that's just going to do the mapping part. It's not doing any of the processing. You can pick any plethora, a number, whatever works best with the machine. Today we're going to show you how basically how GS Pro is going to set up on a M200, and that's what we're using today. Can you use an M210? Yes, you can. Can you use an M600? Yes, you can. There's all kinds of different ways, and then different avenues of the way of the actual mapping software is going to be used to take it. So what I'm going to share with you here real quick is a handout. Hopefully you guys get this, and we'll go ahead and shoot that out to you. If we click on the link down there, and we can see the RMUS Raptor Maps handout. Hopefully you guys can see that. It's open. I'm just going to go ahead and open this and share my page so that you guys can see it. I'll turn off one of my webcams so that we're good there. How's that, Nikhil? Can you see that?
I can see it listed under the handout. So you should all, under
Okay,
handouts, right under questions, there's a PDF link.
Yep, perfect. Okay, so let's just take a look at some of this, some of these stuff that you guys have listed out. Now, this is recommended guidelines from Raptor Maps themselves, and some of the things that when we set these up, we'll go through and we'll actually, again, take a look at GS Pro in just a second, but I just want to go through some of these things that seem to be problematic when you guys are trying to help out or have the correct imagery as far as that goes. And if we're looking at basically the big one that popped out for me was the 80% front overlap and 20 side lap. And when we're doing overlap and side lap, and you can input here whenever you want there, Nikhil. When we're trying to set up the machines to do this, and then we have two imagers on there, I've already done a couple of videos that discussed how trying to take two images from one drone might be a problem. Two separate cameras doing the same thing. You end up with extra data, and you end up with extra stuff maybe from the RGB. But this is really important to make sure that you set up your thermal side to do this correctly. You might have to do two different images or two different missions, and that's really important. So you can do 80% and 20% on thermal, And if we go down just a little bit to a high resolution camera, we can see the overlap set from 80 to 80. And that's a lot of images to get a lot more data as far as that goes. So two different missions that are kind of set up. Everybody collectively wants to do, because the 210 is out, to try and do two images from the same. We just have to remember that if we're going to do data collection like that, that it's very simple to screw it up because you don't have it set up for the proper camera at the time. So you're going to do the lowest number or the highest number. You might have extra data, and that's not always the best thing, is to have extra. But I still maintain the fact that you might want to still do two separate mapping missions here instead of trying to do one with two separate images. So yeah, you John, do want to have.
If I could cut in here and just clarify, I mean, the big thing we're trying to do for you guys is to minimize the amount of time you spend in the field and minimize the amount of data that you need to collect and transfer. And so that's why when you're looking at these guidelines, and that's what John's saying, he's saying, you know, sometimes if you can break it up into two separate missions, and a lot of you may have like an Inspire or something that you have to do that anyway, then you can really optimize and spend, you know, quickly get the thermal data you need, quickly get the high res data you need. And the reason that the 8080 doesn't take as long on the color imagery is because those cameras are, the footprint on those and the resolution is just a lot higher. So it's not like it takes way longer compared to the thermal flight. Actually, they're actually very quick.
Yeah, and I again, so everybody is trying to save time, and if you're already recommending that even doing two flights is actually faster, you know, we can do the high resolution color digital camera recommendation that you have, 250 feet AGL. Your GSD is probably pretty good from that level, depending on, again, camera. But if you're already doing that, you can use this as a reference to possibly doing the next part, the thermal part, if that's the case. If you're going to go out there and do both the same day, again, it can be running one mission versus the next mission, and just for the best data, that's what basically Raptor is recommending. If we may be able to set up some of the mapping software to actually do this, double trigger both the cameras on a 210. It hasn't been really effectively done yet, and to be honest with you, we're still waiting for the pilot app mapping portion to be able to see how exactly that's going to work. But for now, it's just recommended. Even I'm recommending that you try to do two separate mapping missions with two separate data collections. So as we come down here to the bottom of that page, we have the M200 that's listed there at the bottom as far as a gimbal mounted. We have a minimum FLIR radiometric camera with a 640 by 512 resolution, 9 by 13 lens, and this is another cool tidbits of information here. What if you don't have a 640 by 512? What if you don't have a 9 or 13? There's some adjustments. You have a 336 XT, or you have not even XT. You have a FLIR Duo. These, you know, these can be problems if you don't have GPS stamped with them. It just takes that much more processing time. If it's not radiometric images, that can also be taking more time to try and get it right. So just having the proper equipment to get into this space and do this type of work, I mean, you gotta bite the bullet sometimes. We do have people that try to prove the concept to use a lower imaging camera, maybe a 120 imager to see if they can do it. That's fine. But if we're going to do it in this capacity, which Raptor Maps is going to help us to get to this point, we try to keep it as on the high level of professionalism here throughout the whole process. I mean, even to the presentation to your own customers, and that's pretty important. So that does come with a cost. That's, you know, that's something else. That's part of another discussion. But at the end of the day, this is the recommendation. And just a real quick radiometric. I'm going to show you how to kind of trick the camera as far as using GS Pro here in just a minute. But what is the real value to doing radiometric imagery versus not radiometric, Nikhil?
Yeah, so radiometric images are actually capturing, you know, radiometric data for every pixel. So 640 by 512, every pixel's got it. That means that if you have something that may have, you know, thrown off the scaling, so you might have a really bright spot or something like that in there, that's totally okay. All of that data is there and it's preserved. If it's not radiometric, the image is really what you see is what you get. And so, you know, if the scaling's not good, that can be an issue. If it's not quantitative. So, you know, radiometric just allows for a lot more to be done after your flight. Whereas non-radiometric, you know, if you didn't capture it properly, or you want to go back and make some sort of quantitative determination, you really can't.
Okay. And do you find, just another real quick question, do you find whether people are using the standard XT, which is essentially still radiometric, it still carries or can record 14-bit data, versus an advanced radiometric camera? Do you see any real major differences in the in the quality of the images in which they are able to collect, both being still radiometric?
Yeah, if you want to do thermography, you definitely need the radiometric version.
Yep. Yep. Okay, so if you have any questions on this page, I mean, just kind of briefly going through it. File format must be radiometric JPEG or thermal TIFF. Here's another one that's really important, that the gimbal pitch is straight down with a deviation of up to 20 degrees acceptable to avoid glare. Now, glare, to me, has a lot to do with the time of day in which you capture your images. So time of day has a lot to do with it, and not all. Some of the solar panel fields that I've been to, sometimes the panels move throughout the day, so they're not always fixed. So you can have some panels that are slightly angled a little bit different than other panels. Have you seen that in your processing as well, Nikhil? It's not always the same?
Yeah, we've seen everything.
Yeah,
So,
okay,
you know,
sure.
fixed tilt mounts, you know, trackers, you know, multiple axes. Yeah, and because of that, and this is part of where you as the pilots, you know, we want to show you where you have flexibility to be able to take the best data possible. And one of the levers you can pull is in the gimbal angle. And so John's going to show you how to set that up. And then we're going to show you why, basically how to orient your drone so that you can move that gimbal in order to eliminate a lot of the glare.
Yeah. Okay. So, and then another one that's just setting up the speed, especially in thermal, is the motion blur. So, since the most of us are using the XT, and I could say that's basically what everybody is using. Not everybody, but most people are using the XT. There is a certain amount of time that it takes for the actual thermal image to be written to the card. And so that amount of time that can be, as the drone is moving too quickly, can blur the images if you're not careful. So it's a really good number here, no more than 3 meters per second or 7 miles per hour as far as forward motion goes. You can set up some of the software to go ahead and stop, take an image, move on, stop, take an image. But this is just a recommended basically how fast the drone can go, so you don't blur the images and lose any really important data. Let's see. If anybody has any questions on this handout, please.
Yeah, we're available. We'll, you know, if you guys have questions on this, the goal is to put this all out there for you, and you know, we can follow up with blog posts and respond to the questions and things like that. So yeah, just send us all your questions and we'll take care of it.
Perfect. Okay, so let me go back to, all right. Should be able to see me and my screen, I'm hoping.
Yep, I can see you.
Okay, and then I just wanted to show this one picture, and I hope that's going to work out here. That right there. Can we see that image there with the solar field?
Mm-hmm.
See that? Okay, good. All right. Okay, what we're using here is GS Pro. That's basically what I've got right now. One of the reasons not saying that this is a better program or not better program, but this, because it lives in the DJI environment, kind of works well with some of the ships they already have. One of the big things that happens is that when people use other people's or other third-party apps, it doesn't always act right. Others actually work better than the GS Pro. This GS Pro is also only available on the iOS software. The other one, which is Pilot app, which will hopefully, again, we'll see some changes here shortly on being able to use Pilot app and the mapping features of such. We're going to hopefully not have any issues with that as far as setting it up. But I'm going to go ahead and open GS Pro here. And we have an M200 sitting here, and show you a little bit about, just give you kind of a walkthrough on setting the camera up and how we can actually change the angle if needed when it comes down to the system. You know, as far as it's moving along and some of the angles might change, and we can actually manually change those in GS Pro if we absolutely have to. Even though it's flying its mission, we set it initially for nadir, then we can go ahead and tilt it depending on the direction that it's moving. The nice thing about GS Pro is that we do actually have a thermal image that we can watch while it's happening live. And while we can see that thermal image, we can make sure that we actually do have, and that's just a dial on the side, we actually do have the correct tilted angle. During the time of capture, again, I had mentioned about the sun, and the sun being reflecting off the panels, limit that as much reflectivity as you possibly can. Sometimes we get the anomaly. We'll see it. We can see it in the video. We can see it happening, and the imager is taking these pictures as we go. We're just trying to get even a good time of day to do our data collection. I found early morning to be really well, because you can see a lot of anomalies that start to show up very quickly. When we got into solar noon, it ended up being a little bit more problem. It was harder to see because all the panels started to get hot. Everything was hot. And so some of those small nuances of or anomalies that are showing up for individual photocells weren't showing up as well, you know. So we couldn't always see every single one of them. But when we set up the map, you know, this is a map that I had found, or a site that I had already went out and looked at one time, and we can see how we've set up basically the system. We can see that on our page here. We can see how changing some of the numbers will actually change the way that the patterns work. And on the side, let's see if I can grab this other picture. On the side of the panels, we can see, or on the side of the mission planning over here on this side, we can change parameters in the way that the camera, what it looks like, which profile it is, how we're going to do, what it's going to do at certain points, and then making sure that we're doing an actual changing our speed here down, our altitude change. These are all important factors when it comes down to actually setting it up right. And even though, like I said, when we go out and fly, we're ready to do the missions and we're ready to press, ready to go, we are trying to limit the amount of times that you actually have to do this over and over and over again. But if you do need to go out there and practice different levels of when and how to capture the data, there's no doubt that you have to spend this time figuring out how to do that. There's no specific way. You're not going to get it right the very first time. You're going to learn better as you go along, what works, what doesn't work. And so when I initially go out there and I do this map, I might find out again that I've got all the images, they're all there, but then how do I verify the data? When I go back out, I can, again, is GS Pro. When I go ahead and hit OK, GS Pro automatically tells the XT to do JPEG pictures rather than JPEG R. And in JPEG R, that's pretty important to use, as Raptor Maps recommends, is that we can come back out, we can go to the GS Go app, choose the file type we want, and then come back in, upload, and make sure it's actually recording that way. Because you can't really select file types, there is no data that's actually being recorded here as far as the mission of the current flight. We have to ensure that that is happening. So again, we're just using GS Pro as an example. Well, I'll do some more webinar or some more explanations here shortly on how we can set up other programs to do this, and pick your favorite, pick your best. I mean, there's just so many different ones that can do so many different things. So I didn't want to spend a whole lot of time, but I do want to go ahead. I'll actually do another rebroadcast when we get out to the field and show people how I set these up, as well as how we might move forward on collecting the data correctly, and that's really important. So we are Let me go ahead and give this time over to you, Nikhil. I mean, that was just kind of a quick one. I'm gonna turn off my stuff and
all right,
hand that over to you, and you have the floor, my man. I'll try to answer some questions as we're going along here of anything that I can do relative, just shooting some answers while Nikhil is talking. So,
all right. No, that sounds good. I'm gonna actually share my screen here. John, do you want to give me control?
You should now have control.
All right.
Got it?
Everyone see me okay?
Yep, I can see you.
Great. We actually have before we launch into talking a little bit more about the, setting up your flights and then the deliverables part of it, we got a special treat for you guys today. We have the Raptor Maps CTO, Eddie. He's right here.
How's it going?
All right. He's going to give you guys a little bit of a whiteboard talk on basically how you set up your flight plan for flying thermal, specifically for the for solar farms.
Yeah, so I wanted to just, there is sometimes confusion. There's thermal mapping, and then there's our product Raptor Solar, and they can use different flight plans. So I wanted to try to, as clearly as possible, go over those two different types of, flight plans and show you the differences. I think once I explain it on the board, you'll see why the numbers make a lot of sense, can save you time in the field, also save you time transferring data. So I'll go through that. This is heavily detailed in that handout that John provided through us, but this will hopefully illustrate it for you a little bit more. So when we talk about thermal mapping, we usually mean a mapping mission with high overlap. So that's high front lap and high side lap. And for thermal, this is especially challenging usually because thermal images are much smaller and less detailed than RGB images. So if you used to make a lot of RGB maps, you're probably used to flying those. They come out pretty easily unless it's a huge place. But for thermal, you usually need very high overlap. So I got a little scenario for you here. We're going to talk about a 10-acre size solar farm. It's roughly maybe 2 megawatts DC power. So think about a 10-acre field in your head. If you were going to make a thermal map, you want to fly about 90% overlap on your front lap and 90% overlap on your side lap. So let's make sure you can see this here. So that's 90% front and 90% side. So when you do that, you're going to want to fly around 200 feet AGL, above ground level. So we'll say 200-foot AGL. And you can try to fly lower if you want. We've seen this, we make many maps for many people. Once you start flying lower than 200 feet, your map's just not going to come out. That's a function of the algorithms that are used to build up large maps, and it gets very tricky under 200 feet. So if you're going to fly a solar farm and you want a map to come out, you got to fly at least 200 feet. But when you do that, because you're higher, you lose detail. So you might be missing those diode issues, you might be missing cell issues, and also when you stitch your imagery, you're going to get artifact from stitching. So you may not see all the issues that you normally just see in better imagery. So I'm going to put up here, let's assume we do that. I've figured out that that's a roughly, you would take somewhere around 1,900 images. So that's 1,900 thermal images, 10-acre solar farm.
Wow, that is a ton.
Yeah. And the other cool thing to know is, when we talk about mapping, you got to go back and forth. So for this size place, you have 50 passes. So for just a 10-acre field at 90% overlap, you're going to go back and forth 50 times. So I don't know how many battery swaps that is, but I'd imagine it's more than one. Now, if we talk about Raptor Solar, we do processing very different. So we don't make that normal map. We automatically detect defects in single images. So we don't need those same requirements, which lets us go a lot faster. So for Raptor Solar, the best we found, the sweet spot, is around 80% front lap and 20% side lap. So that 20% is going to save us a ton of time. So And because we're not making a normal map, we can fly a lot lower. So we usually recommend about 120 feet. This is assuming a 13 millimeter lens. Different lens might mean a different altitude, but for simplicity, let's go with 13 millimeter. So now because we can fly lower, we're going to get a lot more detail in our image. You're going to be able to see those cell defects. You're going to be able to see those hot spots, the diodes. So it's going to ultimately make a better report. Your client may not care about some of those little things, so there might be some optimization, but for what we've seen, basic deliverable, you want to be able to deliver this kind of quality imagery. And now the cool part is that's about 335 images. So as you can imagine, that's a lot less images you have to take. That's a lot less memory cards you need to have. And when you send all your data to Raptor Maps, it's going to send a lot quicker because you're sending less images. So that's a really cool thing in that. And I figured out that you'd only need about 10 side passes. So 10 passes. So as you can imagine, it's going to take less time in the air, less batteries. So everything about this is faster. So I think that's let me get out of the way so you can just kind of see that for a second. And I'm gonna detail one more thing, which is actually how you fly. So when we think about thermal mapping, I'm going to draw a box here, and this box, that's our solar farm, that whole area there. And if we're going to fly this flight plan, it's going to look something like this, back and forth, back and forth, back and forth. We're flying this way, back this way. You have about 50 passes. And here's where it gets tricky, and I think the most confusion is caused. When you're flying a normal map, you usually think of flying the drone in the direction of where you're going. So when you take a picture, it's going to look like this, because you're flying this way, the drone's facing this way, and you come back. So that gimbal is kind of aligned with which way you're flying. But for solar, what we can do to make it even better for you is fly a little bit differently. So this is our solar farm if we're using the Raptor Solar style flight plan. If we fly back and forth, it's going to be much wider between each pass. We need less passes. But the trick here is that although you're flying this way, you want to point your camera this way. So when you take a picture, the picture is going to look like this. And you fly and then you take another picture that looks like that. And the reason you do that is because the solar panels are going to be lined up that way. So you're going to get the most amount of solar panels, the widest shot in the view. And that helps our software localize those defects a lot faster. It would probably work if you did it the other way. We have been able to. If you happen to do that, we're not going to make you go back and fly again. But if you fly this way, but point your camera the other way, so the image footprint looks like that and lines up with the solar panels, it's going to make our whole process a lot smoother, and you'll get your results faster. So I think that is a little bit of confusion. We have some diagrams on that and how you can adjust your gimbal tilt, but I just want to clarify that. So hopefully, let me step out of the way. Hopefully that kind of clears up the confusion between thermal mapping and how you would fly if you're using the Raptor Solar product. Thank you.
Perfect, Eddie. And there's a lot of different ways that I think figured out.
All right. Thank you, Eddie, for clarifying that. We're going to switch over to show you guys some slides and then pause and then take some questions. So give me a second here. All right, John. Let's see. Can you give me control to share my screen?
I think so. Hold on. Can you hear me?
Yep.
Hold on. Oh. Should be good,
right.
I think.
Yep. Got it. All right. How's that look?
Looks good. Your screen. There we go.
All right.
Yep.
So as you guys this is just really recapping what Eddie just told you, showing you, just to be a little more clear, we put it on the slides as well. So you can actually see 80% image overlap in the direction of flight and how you fly and which way you point the drone. All right, and then this also covers what he just showed you, flying, sideways along the row. And I just want to clarify, when we say overlap and side lap, just to be really clear about the terminology, we say that overlap is what's in the direction of flight, and the side lap is between the passes. So that's how we refer to it. And then just for those of you who are pretty visual people, who want to be able to look at the data and know, the number one question we get is am I doing this right? This is what a typical image should look like. So you'll see as the drone moves that, you can use that little cell defect for reference. You can see that that's moving, and you're flying along the row. All right, this is also highlighting kind of what we were talking about, the difference between, analyzing individual images and thermal maps. So again, with individual image analysis, we can fly a lot lower. We don't have any sort of, when we say artifact, we mean, different, if you've ever made a color map and you've seen kind of weird discontinuities, or if you've ever done like a panorama on your phone and someone's feet are kind of cut off and things like that, that's all the type of thing we refer to as stitching artifacts. It's what happens when you try to blend images together. If you look at individual images, you don't have that. And so we're able to see a really high level of detail by looking at individual images, which is how our software works. All right, so that was all recapping what Eddie just told you guys. Now I'm gonna slow down a little bit and talk about high resolution color images. So the question we get asked quite a bit is, everyone knows thermal for solar makes a lot of sense. You can see a lot of things. So why do I want to collect color or RGB images? And this is just a really good example. These are the types of defects that you can only really identify by having the color imagery. So this is a module, and you can see that the glass is shattered. There's a close-up that you can see right there. Conditions like shattering or soiling or anything that might be physically covering the module, a lot of times, or even shadowing, for example, a lot of times that can show up as hot spots or a warm module, and you may think that oh, this is a cell defect, or oh, there's something going on here. And this RGB color imagery really allows our software to clarify and provide you with a much better deliverable and root cause, rather than just saying, yeah, these are, they're hotspots at, row X, string Y, module Z. We can actually say this is what's going on there. So the other reason you want to collect that RGB imagery is what John was referring, is what he was talking about earlier with, a lot of times these are very new sites and you may not have satellite imagery, and you can very quickly and easily collect an RGB ortho mosaic, so the images that you need to make an ortho, and that'll create a really, really nice base map that we're going to be able to use. All right, I just want to talk a little bit about weather. We get this question quite a bit as well. Sunny days are good. You want to perform the inspection on a sunny day. It may seem kind of funny because we talk about avoiding glare. That doesn't mean avoiding sun. It means avoiding the glare reflecting back into your camera. So avoid flying on a windy day as well. As John said, that really contributes to that motion blur. And you don't want your drone to get kind of blown all around and off rows and things like that. So really a nice calm day is you're going to have a much better time. And then 600 watts per meter squared irradiance, you can kind of look up for your town or your your latitude when that typically would occur, but it's kind of a good rule of thumb for you guys. All right, so we've talked about thermal, we've talked about RGB. We just want to be very clear here that you're typically going to want to have two flights. There's the thermal flight, and Eddie talked about that and why. One thing I do want to mention here is when you set that side lap really low, whatever you're using, whether it's if it's ground station, GS Pro or Pix4D or Drone Deploy or whatever, the software may yell at you, right? Because a lot of times that software is geared towards high overlap ortho mosaics. So that's okay. So we do get a lot of people asking us, well, the software says that. Remember, we're using these software platforms just so we have good, consistent data capture and automated data capture, so you don't have to fly manually. And then the RGB flight, We talked about why that's important, both from determining the root cause as well as creating that orthomosaic. We don't want to go into a ton of these numbers and everything like that. We covered that earlier. You guys have the handout. If you have any questions, feel free to ask us. But what we also do say is, if you already have existing processes in place, or there's certain data products that your clients are asking for that may be outside the norm, this does happen, just shoot us an email, info@raptormaps.com. We're happy to help you out. All right, so now I want to talk a little bit about the reporting. We've spent a lot of time talking about good data capture, and the reason for that is because good data capture makes your reports come out faster, and it also makes them much higher quality. So we want to make sure that you really understand what it means to capture good data. And I really like what John said about practicing. As soon as you have the hardware, go outside and get familiar with it. It's very easy, it's very quick to do. It doesn't really cost you much, so go for it. But once you have that really good data, that's when we come in. So talking about automated software solution for processing solar farm data. That's what Raptor Solar is. We can analyze both the infrared imagery as well as the high resolution color imagery, and we really do want you guys to take both. Now, the really cool thing about the use of drones, especially over the past few years, is we've done some of the largest utility scale sites in the U.S. And abroad, but we've also done a lot of smaller sites, what we call commercial and industrial or non-residential. And that's because there are a lot of people who are out there flying drones in every corner of the world, and that makes it a lot easier for solar companies to find someone to actually go out and collect data on these smaller sites. So these smaller sites are getting a lot more love than they used to, because you're really helping your own clients figure out whether they need to dispatch additional resources, because these may be in other states, it might be on another coast, and you're really helping them put together a good comprehensive inspection to determine whether or not they need to deploy more resources, and make sure that if they need to make any repairs, all the right equipment and everything is already waiting for that technician. The other thing we do with our reporting is it's a very standardized process, and it allows your clients to compare across their portfolios. So they can look at a solar farm in Boston, they can look at a solar farm in the Southwest, and really understand what's going on and make management decisions. That's what it comes down to. It comes down to really good decision making. And finally, it really allows you guys to spend more time, or your clients more time, actually addressing and fixing the issues, and less time reviewing the data. And it's really important to remember the solar industry is growing really quickly. So it's not just about saving a little bit of labor, it's about enabling people to grow their portfolios and capture a lot more territory, because it's expanding so quickly. And so now you're really freeing up the ability for these skilled people to go out and do what they need to do to keep these assets running at peak condition. All right, so I'm going to show you the components of a solar deliverable, and if you're squinting a little bit here, that's okay. You can download this report. We can even send it out to everyone here. So don't feel like you got to read everything on here right off the slide. The point here is to really show you what the good components of an inspection report are. Now, keep in mind, when it's generated from Raptor Solar, this is all, every defect is associated with imagery. It's associated with these boxes that you see around it. It's associated with a loss, an exact location. We have all of that. So everything you're seeing here is pulled from that into a few different ways that your clients may want to see that data and use that data. So it's very structured on our end, and then we're able to generate these reports. So this is kind of the primary report that you'll see, that you'll want to deliver to a client, and the components of it are site information. Typically with a solar farm, and John talked about this earlier, some of them are tilts, have tilt trackers, some of them are fixed tilt, some of them may be on a rooftop. There's different module technology. They're in different locations. So we just want to include some of that very basic information, so someone doesn't have to go back to look at like construction drawings or anything like that and figure out what's going on this solar farm. There's a quick overview of the actual flight technology used to basically capture that data. you'll see examples of the different types of faults that are in that particular solar farm. And then we go into an entire, defect analysis, which areas have the most loss, and what's causing that, and basically really things that help with the asset management. That third page that you're seeing there, that shows every column with all the, you've got different numbers in different columns. That's really helping the technicians find the exact module. So instead of giving them a lot of GPS locations, you can allow the technicians with Raptor Solar to say, okay, I pull my truck in, I just need to count, this many rows up and this many rows over, and I'm going to find exactly what I'm looking for and be able to service that particular part of the solar farm. So the idea is we're making it really friendly for both, the people who receive this, the performance managers or the asset owners, but we're also making it really friendly for the technicians. And so to kind of summarize this here, a good report is going to summarize all the findings by defect type and location. You're going to have a location and an image for each defect, and within that image, it's going to show the exact one, because we've handled a lot of solar farms that have a lot of defects where you're going to get lots of different things going on, even in an individual image. You want it to be integrated into your client's workflow. And this is why when people ask us, why do you provide a PDF and an interactive portal and a KML file and an Excel file? And the answer is because different clients have different workflows, and you need to make it as seamless as possible to work with that. They shouldn't have to go out of their way. You should be making their lives way, way easier. And then you want to be able to track changes over time. And also track changes between different locations. So some of these solar farms, like the one on the sample report, may only be a few megawatts kind of located on one parcel of land. Some of these really, really big utility scale farms, you may want to, we'll break it out by inverter and by location, because it really is, you can almost think of it as a lot of smaller solar farms that just happen to be sitting on one spot, and you want to be able to compare them. And then finally, don't forget that your clients, they also have clients, and they want to be able to share the information with them and show those clients what they're actually, what's going on with their asset and what they're actually doing about it. So these are all different components that we address with Raptor Solar, and we work directly with solar companies to make sure we're meeting their needs. And so what you can see on the left here, and these are also in the sample reports, you'll be able to take a look at that, is the interactive portal where you can actually see, the individual defects as well as the locations and the temperature data and all of that. You'll notice in the bottom left, so that as-built has actually been geo-referenced, so every single defect shows up exactly where it needs to be on the construction drawings that were provided by that client. And then on the right, that just shows you an example of the KML file where, if your clients are using any sort of GIS software, that's something that you can provide them that's gonna pull right in. So it really speaks to the components of these good deliverables here. And so in terms of wrapping up, I mean, that's our goal today is really to show you, here's how you set it up, here's how you collect the best data, and then here's what your clients are going to get. And so hopefully, we've allowed you guys to see that entire process. We want to demystify this as much as possible. It's not rocket science. It just takes some good thoughts, some willingness to look at the resources and make sure you go out there, check your data, and make sure that it's as good as it can be. So I'm gonna pause there. John, did you want to add anything?
No, I think for the most part, everybody gets, at least I understand, the level of reporting here is a lot different than what a lot of the, if you want to call them competitors, I wouldn't necessarily even call them that. The way this works is a lot different than some of the other programs that are out there, by saying so. So it's hard to compare the product in which you create against those other people. Wouldn't you agree? I mean, it's quite different.
Yeah, I think, a lot of times we get asked about, how does this stack up compared to mapping software? And there's fantastic, I think people are under the impression that we compete with software that where you make orthomosaics and things like that, and we certainly don't. We are very focused on asset management, and that's what we do. So,
Yeah.
for example, if you're helping a company in the design phase and you want to do, a topographical survey or something like that, there's great software out there to do that, and we certainly will be the first ones to point you in the right direction. If you're trying to fly a solar farm, though, yeah, you want to come and talk to us.
Yeah. So what I'm getting out of you is that even though, let me do this in comparison. When we do 3D mapping and we're showing 3D, outputs and really mystify 3D nifty model that's been created, I feel the same way when it comes down to orthothermal stitching. Is that sometimes it's really nifty. It doesn't help the end user, and it's neat to see the whole site done in thermal, but I understand why people sometimes think that they need that. That was actually one of the is and I'm getting from you that it's not needed,
Yeah, I mean, we work directly with the companies that are actually, receiving the reports, using the reports. I mean, you saw that shattered module. That was actually, one of our employees out in the field validating something with a client. And so, yeah, it really comes down to what do the people who are actually using this data need, and they need it to be detailed and accurate. The mapping part of it is it's exactly what you're saying. It's beautiful. It can be good for marketing. It's not a good, consistent deliverable that you can use across an entire portfolio.
Yeah, and that totally makes sense. So we've got roughly 10 minutes or so to answer some questions, and I'm happy to stay on the line a little bit longer if we need to. But I'll try to hit as many as these that are kind of both technical as well as relevant to Raptor Maps as far as some of these questions. And so let me see. One question is, what about EL, electric luminescence, when doing PV inspection? Any input on that?
Yeah, so EL, that is a pretty separate process. That if you want to know more about that, we can definitely talk about it, but it's not something that's very commonly done, and it's not something that your typical drone service provider is gonna be doing.
And so that was kind of a technical question as far as like just how it would help out one of our listeners, Dennis. Let's see. I don't know if you can see any of these questions, but
no, I can't. So
maybe you can go into. So Paul, he asks, what are the main deliverables that some of your clients ask for? You touched on a whole lot of different ones, but what are some of the most common ones that people ask for?
Yeah, so the most common ones are surprisingly the Excel file, because they want to be able to go and take every single defect and know where it is and filter it down by the different sections and things like that. And then the PDF report is also very common, and the reason for that is it's less about the file format and more just about the actionability. And so what happens there is you're getting not only the defect types, but how much of the capacity is it affecting. And so a lot of times you're able to say, capacity as in power. And so you're able to say, okay, for 10 minutes of my technician's time, or maybe an hour of my technician's time, I can really address 90% of the power issues that are happening on this solar farm. And so those are the types of decisions that this enables. And so that's why that type of breakdown is so popular.
Okay, yeah, gotcha. A couple of technical questions here for me. From Alvin, does GS Pro work with the N3? Well, GS Pro would have to run through the LB2 basically. So as long as you have an LB2 connected to the N3, I have done N3 and A3 mapping with the Lightbridge 2 connected to GS Pro. I have done that. So just to answer that question. From Sunny, I've got how do we record both XT and Z30 images? I would assume that you have likely a 210 And here's one thing about the Z30, doesn't make a really great mapping camera. It's not, it wasn't really designed for that. So you're usually best using an X4S or the X5S if you're running a 210. And then the next follow-up question, where this is probably the most common one I'm getting right now, is how will the XT2 perform while doing mapping? Now that is a very difficult one to tell you here right now, because it's still running 2 imagers. The RGB does actually do pretty good as far as taking single imagers, but I don't know if the mapping mission, you know, like I said, if you're going to be setting this up to get the best images from a camera that doesn't have the same view, it doesn't have other things. I mean, it's just still just went down to the release of the XT2, probably more feasible to be used in public. The tools that are there kind of fall into that category. So as soon as I get one in, we can start doing data collection. I'll get this information over to Nikhil and his team. He can decide or not an XT2 and recommend whatever is going to be working. So we still have a lot of questions and unknowns as far as how the XT2 is going to perform in a mapping type mission. So just an FYI. Let's see. Roy Boyd has asked, have you processed any data from the Falcon 8, basically the Intel? Have you used that ship, or have you had anybody use that ship as far as helping or giving processing to you? Has that happened yet so far?
Yeah, so we're platform agnostic. We've seen obviously a lot of DJI data, Sunfly data. Falcon, we actually haven't processed any from the Falcon 8, but as long as you're following the guidelines where it's radiometric and there's a appropriate metadata in there, you know, that shouldn't be any issue. So, you know, if you have any follow-up questions on that, or you want to send us a few images and say, hey, is this going to work okay with Raptor Solar? You're more than welcome to do so.
Very good. That answers that question. Is like I said, like Nikhil said, we can use pretty much any ship out as long as certain data is there. It definitely helps their workflow as well as your own to get the correct data to your customer. So.
And John, while you're selecting the next question, I know some people may have a hard stop at the end of the hour. So I do want to say that if we didn't get to your question, you know, we will be posting a follow-up on the blog, you know, basically a recap of the Q&A.
And then the technical questions that actually come through with technical questions that I responded to on the last webinar, and we'll do the same. That some of these are very good questions, and as well as how they might work. So, yep, if you need to get out of here, that's fine. I'll just try to finish up a couple more that might be kind of relevant. Here's one for you specifically, Nikhil. Is Radiometric pricing based on number of reports, analysis, or size of analysis? Our sites are a lot smaller than the US. To become expensive if based on the same factors as, say, US customers. So just the beginning of that was the pricing based on a number of reports, analysis, or size of analysis?
Yeah, that's a great question. So it's actually based on a few different things. One is the if by size of analysis you mean the capacity, or basically how big is the solar farm, that's definitely part of it. The number of sites, you know, typically customers that, you know, if they're able to come to us with a portfolio, so a lot of our customers are larger companies that, you know, manage assets, you know, all over. We're able to provide pricing discounts for that. Yeah, so there are a lot of variables there, and the reason for that is because of exactly someone in that situation where they may say, well, you know, I've got a whole portfolio, you know, that's typically between this size, and this is the level of analysis, and, you know, we're almost always able to make it work for that customer. So yeah, I would say definitely give us a call.
Yeah. Okay, so I'll do this last question, and the one is basically the development of the solar farms as we move forward. There's lots of comments here about yours main guys, people that are bringing in a drone service provider to actually work, and how they currently monitor their own site. So O&M is the guys that I worked with. Their systems did not to be able to look at individual panels. They're the largest, or the space and the number of panels that were connected to a basically in parallel was almost 10 acres big by itself. So 10 acres big, and they aren't able to define exactly what it is. That's actually where it falls into play. Also walked around with handhelds and looked at every single panel in order to evaluate the discrepancy or the break or the crack or the whatever it might be. They actually walked through every single one of those spaces with a handheld thermal camera and took images of those, of the defective areas. You know, as far as Carlos is coming here, solar farms using thin photovoltaics, sorry, and other PV controls. Yep. Each of the panels are capable of giving information, which also makes it not necessary for possibly using a drone for this type of stuff. Well, it isn't about selling these guys on the fact that you've got with an XT and got a subscription basically, or some help from Raptor Maps. What you're trying to do is the biggest problem we have with anybody does out there when they're just getting asked about it, is that most of the time the drone service provider is not educated enough to actually deliverable going to. And that's really difficult. When people ask me general questions, you know, do you do thermal? Yeah, thermal. Well, then I need thermal stuff, not building. It's several stuff that, well, what thermal stuff do you need? Do you have solar panels? Do you have broken space? What is it that you need? And a lot of things qualify for. I think educating your customers also comes down to actually doing some of this work and working with some of these other companies that may need it, but you don't have to actually do. So hopefully that helps out a little bit of ideas on where you want, how you want to not only just collect the data, how to get it over to Raptor Maps and correctly getting it, you know, so that we have good, helpful data. And we did want to touch on a little bit, making sure that even before you leave the field, that we have the data that's important. It's there, and it's not, you know, it's not crap. Double checking that, making sure before you leave the space that you got the data that you need. And if you had anything else to add, Nikhil, I'm happy to hear. And again, we want to just thank you and Eddie for showing us a little bit about how Raptor Maps their thing.
Yeah, absolutely. You're welcome. And keep the good questions coming. We'll post a follow-up. And yeah, thank you everyone for your time today.
Okay. All right. Thanks, guys. And just remember that we are having an actual level 1 thermography class coming up on May 9th. This will help understanding, just not on just mapping and doing the data collect, but also understanding exactly how thermal works and having the certification that kind of comes along with it. That is a standard certification. So in Salt Lake City, May 7th, we'll be at. So if more information, sales, rmus.com. Again, sales at rmus.com for any of the level 1 thermography class that's coming up. Hey, just remember, we're a bunch of drone guys. That's what we do. We create, we make, and we'll have a lot of input when it comes down to the thermography class when it's here. Again, thank you so much, Nikhil.
Absolutely.
Okay, and we'll see you guys next time, and we'll have this recorded and shown to everybody. Thanks, guys.
All right, take care, everyone.